Hi Year 11, this video is going to take you through titration calculations. What I do want to point out is this is for higher tier only. So if you are sitting the foundation paper, this is not a video you should watch. But I'm going to take you through how to do the titration calculation. I know some of you from speaking to you, you find it a little bit tricky. So what I've done is I've purposely scaffolded it to give you the layout, because there is a formula to this to help you to then be able to answer the question. Okay, so we'll start off with, we'll do some worked examples together, and then I'll get you guys to pause the video and give the questions a go, and then I'll then take you through the other ones. So first of all, what I want to tell you is that when you're asked to do a titration question, it can vary, but it's between 3 to 5 marks, depending on the level of the question. What you will always get as part of the question is a symbol equation, because we need to be able to do something around what's called ratio. So we need a symbol equation to be able to do that, and they will provide that for you within the question. What you won't get is a table like this, but this is how I break it down, and then we can then use that model in an actual exam question to help you. So what I like to do also is I like to write around the actual equation just to keep myself right. So we'll get started, we'll jump straight in. So it says 25 centimetres cubed of 0.2 molar barium hydroxide solution. Okay, so you've then got to work out which one of these is barium hydroxide. Well, we should know that this here is barium hydroxide. So barium hydroxide, it says from the question that I have got 25 centimetres cubed and a concentration, and it's important you know that that unit there is for concentration, of 0.2 molar per decimetres cubed. So I'm going to basically take the numbers from the question and I'm going to put them into my table, and I'm also going to put them around the equation just to show you how I would lay this out. So concentration for barium hydroxide is 0.200, and we get that from the question. And the volume of barium hydroxide is 25 centimetres cubed. However, can you see how the volume should actually be in decimetres cubed? So I have to convert 25 centimetres cubed into decimetres cubed. And we do that by dividing it by 1,000. So you get your calculator, you plug your numbers in, 25 divided by 1,000 gives me a value excuse me, of 0.025 decimetres cubed. Okay, I then read the rest of the question. It then says it has reacted with 22 centimetres cubed of hydrochloric acid. So here's my hydrochloric acid. I can see it's reacted with 22.8. However, again, it's not in the right units. So I have to divide that by 1,000 to get it into decimetres cubed, which equals the number you can see on the screen. And I've then got my volume, but it's asking me to calculate the concentration. Okay, and that's the part I don't know. And I have to then be able to work out what that actually is. And there's two things I need to be able to do that. The first thing I need to look at is something called the ratio. Okay, so I can quite clearly see, the ratio of barium hydroxide to hydrochloric acid is a 1 to 2 or 2 to 1 ratio. So I'll put barium hydroxide as a 1 and hydrochloric acid as a 2. So I know that if I work out the moles of barium hydroxide, to get the moles of hydrochloric acid, I would have to double that because the ratio is double. Okay, so how do I calculate moles? Now this is a calculation you just need to know, and I'm afraid you have to learn it. And I'm putting it into a triangle. So we've got moles at the top, we've got concentration, and we've got volume. And you need to remember that volume is in decimetres cubed. So for barium hydroxide, I have got my two values I can use to calculate the moles. So I would do the concentration, which is 0.200, and I'm going to times it by the volume in decimetres cubed. So times by 0.025, and that gives me a mole value of 0.005. Now, I can use my ratio, okay? So I can see from the equation that there's 1 barium hydroxide to 2 hydrochloric acids. So if I wanted to work out the moles of hydrochloric acid, I would just have to double that. So I times it by 2. So there is my moles for hydrochloric acid. And this is where you then have to rearrange your equation. So I want to find out concentration. So I cover over concentration on the triangle. And to do that, I would do moles divided by volume in decimeters cubed. You can see I've got the moles value there, and I've got my decimeters cubed value there. So I would do 0.01 divided by 0.0228, and that gives me a concentration value of 0.4. Now, depending on what they ask you in the question, we're going to say 0.44. And that there is your answer. Okay? So, lots to think about, lots to make sure you sort of keep right in your head. You have to know your equation, okay? You have to make sure you convert your volumes. You'll always get one of them to be able to work out the moles, and then it's important you look at the ratio. So let's look at the next one. Again, what I'd suggest, if you think you've got that and you think you know what you're doing with this, I would suggest you actually just pause the video here and go on to try and do the questions yourself. Again, I will go through this for those of you who are still not quite sure from that first example. So, like I said, if you feel confident you want to give it a go, then please pause the video and I will then go through it with you. Okay, so if you've tried it, fabulous. Let's see how you've got on. Remember, I've got to know these 4 things. So concentration, volume, moles, and ratio. And all of the information I need is in the question. This is actually an exam question. So what I'm hoping you will see, as I've already said, you will have the symbol equation to help you work out the ratio, which comes later on when it comes to working out moles. So the question says I've got 25 centimeters cubed solution of sodium hydroxide. So I look at both my reactants. I've got to work out which one is sodium hydroxide. This one here is sodium hydroxide. So I'm going to put sodium hydroxide in my table because again, we're scaffolding this so we can break it down for you in terms of what you need to do. And it says I've got 25 centimeters cubed of sodium hydroxide. So I've got 25 centimeters cubed, but it's got to be in decimeters cubed, so I divide it by 1,000. We've already done that in the previous question. And there we go. All right, so we've got our decimeters cubed value there. So that amount of sodium hydroxide is required, okay, solution required 21.5 centimeters cubed of 0.1 moles per decimeters cubed sulfuric acid. So my second thing I'm looking at is my sulfuric acid, which is one of the 3 acids you need to know the formula for. So H2SO4 is the formula for that. And I can see that I've got my volume of 21.5, which again, I'm dividing by 1,000 to get it into decimeters cubed. Now, I know it seems straightforward, but I would always put things into a calculator just to double check, okay? So I've got my volume and I have this time a concentration value from the question of 0.1. Now what I don't know is I'm being asked to calculate the concentration of sodium hydroxide. That's what I'm trying to work out. And here it's telling me I've got to do this to 3 significant figures. So this kind of question is usually a 4 marker where you get a mark for actually putting it into the right significant figures. So then we do what we've always done. We have one that we know. So this is the one that we can actually work out the moles for. Again, I want to check the ratio. So it says I've got 2 sodium hydroxides for every 1 sulfuric acid. So again, my ratio, if I can work out the moles for that, double that will give me the moles for sodium hydroxide. And I can tell that from the number in front. There's no number in front there, so that means 1. Okay. So to work out moles, I do my triangle to keep me right. Moles, concentration, volume. So to work out To work out moles, I'm doing concentration times the volume. Okay, so concentration is 0.100 and I'm timesing it by 0.0215. And I'll plug that into the calculator. So 0.100 times 0.0215 equals 0.00215. Now, what I will say is sometimes you might put this in standard form. That is absolutely fine. Okay, so just be aware, you're absolutely fine to do that. But I now look at my ratio and I can see that actually I have to double the moles in order to work out the moles for sodium hydroxide. So I'm timesing that by 2, and that gives me a mole value of 0.0043 for my sodium hydroxide solution. So now I want to work out the concentration from the question. That's what it's asked me to find. So I cover over concentration, and I do that by taking the moles and dividing it by the volume. Here is my mole value, here is my volume value. So I'm doing 0.0043 divided by 0.025. And that gives me a concentration value of 0.172. It asked me to do this to 3 significant figures. So as you can see, I've done that to 3 significant figures. Okay, so that is the types of questions you will get. Like I said, you will not have the table, but you can write things around the actual equation. And I'll do that for the next examples. But again, I would pause. You've got about 3 examples to work your way through. Pause the video, give it a go. And then, like I said, come back and we'll then do it together. And this time I will write around the equation just to show you how I would actually do that. Okay, so let's see how you've got on. So it's asking me in this case to find the volume of 1.2 molar hydrochloric acid that reacts with 25 centimeters cubed of 1.5 sodium hydroxide. And again, I'm giving my answer to 3 significant figures. So this time it's asking me to calculate the volume. Okay, so this is not a concentration question, this is a volume question. So I put my 2 reactants into well, we said about not doing it on the table, didn't we? So let's see. We've got 1.2 hydrochloric acid, so 1.2. I'd write that number around there like that. I don't know the volume because that's what I'm going to calculate. I've got 25, but I've got to divide that by 1,000 to get it into decimeters cubed. So that's 0.025 of 1.5 sodium hydroxide solution. My ratio is 1 to 1. Okay, so whatever I work out here for my moles would be the same over here. Okay, so I'm working out moles, which is concentration times by volume. So 0.025 times by 1.5 for the sodium hydroxide gives me a mole value of 0.0. So I'm just going to put this over here now. So NaOH, HCl, 0.0375. The mole value would be the same for the hydrochloric acid because it's a 1-to-1 ratio, 0.0375. I'm then being asked to calculate the volume. So again, I put my triangle in play where I do moles, concentration, and volume. And to work out the volume, I would do my mole value divided by the concentration value, which we got within the question. So I do 0.0375 divided by 1.2. So that equals that number there. And it's asked me to do this to 3 significant figures. So I would do them 0.0313 would be my answer in that case. Again, because it's volume, the units would be decimeters cubed. And it might be a 5 marker because they're looking for you to show awareness of the fact that it's decimeters cubed. So just be mindful, just look at the marks, we'll use that to help guide you. Okay, next one. We have 25 centimeters cube of arsenic acid required 37.5 centimeters cubed of 0.1 molar sodium hydroxide for neutralization. Here is the equation. So it's again these 2 that I'm looking at. This is the acid that obviously it's given me the formula because it's not one that you're supposed to know. There are only 3, hydrochloric, sulfuric and nitric acid is the ones you need to know. So I know I've got 25 centimetres cubed of that acid. I don't, however, know the concentration. That's what I'm trying to work out. Here I have got 37.5 sodium hydroxide and 0.100 for my concentration of sodium hydroxide. So I'm going to put my sodium hydroxide there. I'm going to put my arsenic acid there. And I'm then going to plug everything in. So my volume for my sodium hydroxide was 37.5, but I know I have to divide that by 1,000. So 37.5 divided by 1,000 is 0.0375. And the concentration I have for that is 0.100. And again, I got both those numbers from the question. And my arsenic acid here is got we don't know the concentration, we're trying to find that out. But we know that it's used 25 centimetres cubed, so 25 divided by 1,000, 0.025 decimeters cubed. I then have to work out the moles for the one that I know and then look at the ratio from the question. So to work out moles, I do concentration times by volume. So I do 0.100 times by 0.0375, and that gives me a value for my moles of 0.00375. The ratio is 3 to 1. So for me to work out what arsenic acid's molar ratio would be, I'd have to divide that number by 3. And that would give me the value of 1. Okay, so just be aware that's what we're doing in this case here. So I've worked out the moles, I have my volume, and now it's about putting it into the triangle. Concentration, moles, volume. So to do my concentration, I take the mole value. So in this case, what I've got on my calculator there, and I'm dividing it by 0.025, and that gives me a value of 0.05, like so. And there you go. That's how you would do that one in particular. Okay, and then the final one before you do the exam questions is this one here, where I've got a volume. So again, it's been asking me to calculate the volume, and we'll come to the triangle in a sec. I have a concentration of calcium hydroxide, so I've got to work out which one's calcium hydroxide. So this is here. So I've got 0.04 molar decimeters cubed of calcium hydroxide, and it neutralizes 25 centimeters cubed of a 0.1 molar nitric acid. So my nitric acid is here. It's 0.100 is the molar, the concentration from the question. And I have a volume, but as you know, I've got to divide that by 1,000, like so. And I don't know what the volume is in this case of calcium hydroxide. So I have to first of all work out the moles for the one that I know. So this is the one that I know, where if I plug it into the calculation, where we've got moles, concentration and volume, I'm being asked to work out the moles first. So I do my concentration times by the volume. So 0.025 times by 0.1 gives me a molar ratio of 0.0025. And I know from the original equation that this is a 2 to 1 ratio. So I have to divide that by 2 in order to get the value for this moles over on this side. So I'm dividing that by 2. And that gives me a mole value over here of 0.00125. Now don't forget, you'll have a whole load of space that you can write this information down on. So this is my moles. I'm being asked to calculate the volume. I have my concentration value from the question. So I cover over volume and I do moles divided by concentration. So my moles value 0.00125 divided by 0.04 gives me a volume, and I've got to do this to 3 significant figures of 0.0313. Again, this is in decimeters cubed. And if I had to then convert it into centimeters cubed, I would just times by 1,000. Depends on the question. Okay, so the final thing we're going to look at is some exam questions on this. As I said, you will have plenty of space to write your calculation in. Again, I would just literally pause the video. Hopefully you feel a bit more confident about doing titration calculations. Pause the video, give it a go, and then come back and see how you've got on. All right, so let's see how we've got on then. All right. Can you see how I'm going to write around the equation? You've got the equation, that's what you're always going to have. So just be aware that that's where you can start writing numbers around. So it says sodium hydroxide neutralizes hydrochloric acid. Lots of sciencey words there. In the equation shown below, the student found that 27.2 centimeters cubed of 0.1 moles per decimeters cubed sodium hydroxide. So I'm going to go to my equation and I can see that this here is my sodium hydroxide. I've got 27.2 in terms of the volume and I have a concentration of 0.1. And I've got that from the question and I've written those numbers around there. It says that has neutralized 5 centimeters cubed of hydrochloric acid. So again, I've got my volume for hydrochloric acid there. I have to calculate the concentration. Now that's the thing I don't know. And I've got to make sure I give my answer in 3 significant figures. So I would always, to keep myself right, put the equation on the side that I need. And that's going to help keep me right. Remember, volume needs to be in decimeters cubed. So I'll start with my sodium hydroxide because I've got to work out the moles that I have for my sodium hydroxide. So the first thing I have to do is for sodium hydroxide, I have to convert 27.2 into decimeters cubed. And remember, you don't get marks in calculation questions unless you show you're working. So I'm showing my working and I've got 0.0272 decimeters cubed for my sodium hydroxide. I've then got my concentration value. So to work out the moles, I'm timesing the volume by the concentration within the question. So I'm timesing that by 0.1. And that gives me a molar value of 0.00272. Now I look for my ratio. So I'm looking at my question. I can see the ratio is 1 to 1. So whatever I've worked out here would also be the mole value for over here. So I know that for hydrochloric acid, it has a mole value of 0.00272. I've been asked to work out concentration. So there we go. I do my mole value divided by the volume, but the volume has to be in decimeters cubed. So I take 5 and I divide it by 1,000. And that's going to give me my volume. And then essentially I'm taking that number there to work out the concentration. I would do 0.00272 divided by 0.005. And that's going to give me my concentration of hydrochloric acid divided by 0.005. And again, it's asked me for 3 significant figures, which to be fair, it is in fact in. And there you go. That's how you do that exam question there. Okay, let's look at the next one. Hopefully, again, you're giving it a go. If not, pause the video now and give it a go. So I've got 13.3 centimeters cubed of 0.005 citric acid. Okay, so I've got to look for the citric acid here, and it was used to neutralize 25 centimeters cubed of sodium hydroxide. It's asking me to calculate the concentration of sodium hydroxide. So I know that's sodium hydroxide, so this here must be my citric acid. So I'll start with my citric acid. I've got 13.3 centimeters cubed of that. And I've got 0.0500 in terms of the concentration. And it's neutralizing 25 centimeters cubed of that. But I don't know the concentration. I've got to work that out. Again, I'm going to keep myself right. Moles, concentration, volume. Always write the triangle out. It helps the examiner see your thought process as well. So the first thing I have to do is get it into moles. So I've got to do the one that I know. So this is the one that I know. So I know that citric acid, has a volume of 13.3, but that is in the wrong units. I have to divide that by 1,000 to get it into the right units. So that's 0.0133 decimeters cubed. To then work out the moles, I'm going to do concentration times by volume. So 0.0500 times by 0.0133 gives me a molar value of 0.0000665. Again, it could be in standard form, that's fine. Then the key is ratio. I want to look at the original ratio to see how the mole value would transfer over. So that is the value for this one. I can see that sodium hydroxide is in fact a 3:1 ratio. So I have to times this by 3 in order to get the mole value for sodium hydroxide. So sodium hydroxide, if I'm being asked to calculate its concentration, I do the mole value, which is 0.01995, and I'm dividing it by the volume, which we have to convert because it's in centimeters cubed, so we know already that's 0.025. So I'm dividing that by 0.025, and that gives me a concentration of 0.0798. It's not asked me for significant figures, so I'll put it in as it's came up on the calculator. So hopefully you find that useful, Year 11. If you have any questions about it, you know you can always ask. Please don't hesitate to ask me during lessons, but hopefully that's helped break down for you how to do titration calculation questions. All right, thanks guys.